China has just revealed a humanoid robot that can instantly copy every movement a person makes. Punches, blocks, precise maneuvers, almost like a real-life digital twin. This breakthrough blends advanced robotics with motion sensing technology in a way the world has never seen publicly. In this video, we'll explore how this system works, why experts are calling it a turning point for intelligent machines, and what this could mean for the future of high-risk operations. China's newly showcased motion-controlled robot stands out because it does something remarkably simple yet incredibly difficult. It mirrors human movement with almost no perceptible delay. The demonstration took place during the 12th International Army Cadets Week, where participants from multiple countries observed the system in action. What caught everyone's attention was not its size or appearance, but its responsiveness. This system relies on a motion-sensing suit equipped with distributed sensors that detect joint angles, body orientation, and velocity. The information is transmitted in real time to the robot's internal processor, where algorithms translate the data into coordinated limb movements. The remarkable part is not the transmission of data itself, but the accuracy of translation. Human motion is subtle. Small balance corrections, slight rotations, and varying force levels happen automatically in our muscles. For a robot to copy these nuances, its internal architecture must combine advanced motion control, fast response servo motors, and predictive algorithms that smooth out the signal without creating stiffness or delay. Observers noted that the robot moved in a way that looked surprisingly natural, not the slow, mechanical steps often associated with early humanoids. This hints at significant progress in China's humanoid robotics sector, where companies have been developing robots with highly dynamic limbs, improved joint flexibility, and real-time stabilization. The system demonstrated during the event did not wobble or hesitate. It maintained stable posture through rapid changes in balance, which suggests the platform likely incorporates data from multiple onboard sensors, including gyroscopes and force detectors. The demonstration also highlighted how motion-controlled robots can be adapted for complex training environments. Instead of pre-programmed choreography, these machines respond to human intention in the moment, allowing instructors and trainees to interact with technology that responds like a physical counterpart. This capability can open new opportunities for practicing precise techniques, operating in simulated environments, or performing tasks where human presence may be limited. What makes this especially notable is not just what the robot did, but how confidently it did it. The smooth replication of physical action signals that the underlying technology is maturing rapidly, and it shows that motion-controlled robotics may soon step into roles once limited to direct human involvement. To understand why this motion-controlled robot advanced so quickly, it's important to look at the broader robotics ecosystem developing across China. Over the last several years, China has invested heavily in humanoid platforms, industrial robotics, balance control research, and AI-powered coordination systems. The result is a wave of new commercial and scientific robots that perform tasks once considered unrealistic for machines with a human-like structure. Civilian robotics companies have produced robots capable of walking across uneven terrain, performing workouts, demonstrating martial arts-inspired movements, and even maintaining balance after receiving unexpected external force. These capabilities emerged because developers refined actuation systems, the motors, joints, and controllers that give robots smooth movement. Many Chinese manufacturers now build compact actuators powerful enough to support jumping, sudden turns, and quick directional adjustments, which directly benefit any robot that needs to follow human motion accurately. AI has been the other major driver. Through advanced perception algorithms and lightweight machine learning models embedded directly into the robots, engineers have made it possible for humanoids to interpret sensor data at high speed. This is what allows movement to appear natural rather than robotic. The algorithms estimate the user's intentions, apply predicted trajectories to avoid jitter, and adapt foot placement or arm positioning automatically. Without this, motion control would feel rigid and inconsistent. Furthermore, China's industrial robot market, currently the largest in the world, has given engineers access to large-scale testing environments and mass production pipelines. When hundreds of thousands of robots are built each year, components become cheaper, research becomes faster, and high-quality hardware becomes widely accessible. Technologies developed for warehouse automation, assembly lines, or healthcare robots often find parallel use cases in humanoid platforms. This is why the robot shown at the cadet event did not feel like a prototype assembled in isolation. It was the product of a national environment overflowing with robotics talent, rapid iteration cycles, shared component libraries, and government-supported research centers. China's robotics sector blends academia, private industry, and large-scale manufacturing, accelerating development beyond what individual labs could achieve. One of the first implications is how such robots can transform training and simulation. A robot that mirrors human movement gives instructors a new way to analyze posture, coordination, and reaction timing. Instead of watching a trainee alone, they can compare human movement with a robotic reflection to identify inefficiencies or improper stances. The system also allows teams to create realistic practice scenarios where human and robot interaction becomes part of learning. Another implication involves improving safety in environments where humans face exposure to heat, chemicals, debris, height, or instability. Because the robot replicates movement, a specialist can remain in a safe location while the machine handles the physical aspects of the task. Its humanoid structure makes it capable of interacting with tools, navigating tight spaces, or performing fine motor tasks that traditional machinery cannot replicate. The demonstration at the cadet event also showed complementary robotic systems, including an AI-guided robot capable of identifying buried objects and a device operated through voice control. These technologies highlight a trend. Robots are becoming more intuitive to command. Instead of complex joysticks or computer interfaces, natural human inputs, speech, body motion, hand movement, are becoming the control language. Looking forward, the advancement of motion mirroring humanoids raises thought-provoking questions. How much autonomy should such robots eventually have? What safeguards are needed to ensure they act predictably? How can they best support people while staying under responsible supervision? As AI becomes more sophisticated, robots could gradually gain decision support features, stepping beyond passive copying and assisting with task optimization or safety monitoring. The real importance of this demonstration lies in what it represents: a moment where robotics and human capability merge more naturally than ever before. It signals a transition from robots as tools to robots as responsive partners, machines that reflect human skill while extending human reach into places previously inaccessible or unsafe. This breakthrough shows how quickly intelligent robotics is evolving, blending human skill with machine precision. As these systems mature, they will redefine how we handle complex tasks, training, and high-risk environments responsibly. If you enjoyed this video, don't forget to like, share, and subscribe. Thank you for watching. See you next time.